Hello, classmates. In this lesson, we will introduce Chapter 8, Functional Inks. In this chapter, we will learn about several types of functional inks. Functional inks refer to inks that have certain components added to give them optical, electronic, physical, biochemical properties, or surface processing and decorative properties for the substrate. Anti-corrosion inks. Anti-corrosion inks are inks with chemical corrosion resistance. Their function is to preprint on parts of a workpiece that do not require processing, for example, corrosion, electroplating, welding. To form a corrosion-resistant or electroplating-resistant, solder-resistant film. Representative inks include corrosion-resistant inks, electroplating-resistant inks, and solder-resistant inks for manufacturing printed circuit boards. A. Corrosion-resistant inks. These are acid-resistant anti-corrosion inks. Available in UV-curable, solvent-based, and water-based types. UV inks have become the mainstream due to their high printing efficiency. After printing, they are cured with UV light, then etched with ferric chloride and cupric ammonium, and finally dissolved and peeled off or swollen and peeled off with dilute alkali. Water-based types are generally used as corrosion-resistant films for aluminum evaporated coatings. B. Electroplating-resistant inks. In the production of printed circuit boards, inks printed on non-electroplating parts during the electroplating process are electroplating-resistant inks, including solvent-based and UV-curable types. C. Solder-resistant inks. These inks are printed on circuit boards with completed circuits and patterns to prevent circuit corrosion, insulation degradation due to moisture, solder adhesion to unintended areas, and copper contamination of solder baths. They come in thermosetting and UV-curable types. Conductive inks. Conductive inks are paste-like inks made by dispersing conductive fillers, such as gold, silver, copper, and carbon in binders, commonly known as paste inks. Gold-based, silver-based, copper-based, and carbon-based conductive inks have been commercialized for use in printed circuits, electrodes, electroplating bases, keyboard contacts, printed resistors, and other materials. A. Gold-based conductive inks. Gold powder has stable chemical properties and excellent conductivity but is expensive, limiting its use to thick film integrated circuits. B. Silver-based conductive inks. Widely used for conductive printing in membrane switches. When the substrate is polyester, silver powder can be dispersed in a polyester resin binder to form a paste-like conductive ink. If the ink film is poorly dried, the resistance value will decrease. So it is best to dry it at 120 to 130 Celsius degree with a far infrared dryer. C. Copper-based conductive inks. Copper is cheaper than silver, but prone to oxidation. Now, antioxidized copper powder is often used, and circuits printed with this ink are less likely to oxidize. But the antioxidation effect is lost after high-temperature treatment. D. Carbon-based conductive inks. Fillers used in carbon-based conductive inks include conductive channel black, acetylene black, furnace black, and graphite, with resistance values varying by type. They are mostly used in membrane switches and printed resistors. The former is usually printed on polyester substrates. So like silver-based conductive inks, they use polyester resin as the binder. Liquid crystal inks. Liquid crystals, LCs, are an intermediate state, exhibited by certain organic substances within a specific temperature range. In this state, the molecular arrangement of the substance has directionality. The optical properties of LCs change under the action of electricity and heat. LCs are sticky liquids, and since organic solvents can destroy their function, they must be encapsulated during ink manufacturing. Liquid crystal capsules have a particle size of 10 to 50 micrometers and are added to the binder at 25 to 50%. During LC printing, forming a uniform film thickness is crucial for color display. Fluorescent inks. Fluorescent inks for screen printing are made with fluorescent pigments as colorants. Fluorescent pigments are prepared from fluorescent dyes and synthetic resins with a particle size of 5 to 15 microns. Fluorescent inks for screen printing are suitable for printing on paper and ethylene films. Paper-based fluorescent inks come in oxidation drying and evaporation drying types, while those for ethylene films are evaporation drying. That's all for this course, classmates. See you in the next lesson.